Hello, I'm Vince Marino, and welcome to my Lunch and Learn. Today, I got a great guest and a new friend, George Johansson. He's with AW Chesterton. Now, I'm going to share my screen. I want to show a little bit about uh, you, George. You're the global industry leader in the pulp and paper area for AW Chesterton. I was looking up AW Chesterton a little bit, but anyway, if you or anyone you know needs a lunch and learn, give me a shout at Vince at empoweringpumps.com. George, welcome to my lunch and learn. Like I said, you're my new friend, and I'm super impressed with some of the background and history and some of the developments that you have pioneered. So I'm honored to have you on here. So why don't we start from the beginning? When we talked last, and you told me a little bit about some of your products. And the best part about this is they relate to sustainability as far as water in the pulp and paper industry, to say the very least. I'm sure there's more than that that you can share. So tell us a little bit about yourself, George.
Well, I've been with Chesterton for 43 years. So just kind of getting started. And the interesting thing is I'm a certified cheesehead. That means that I was born and raised in Wisconsin. So I was born right in the thick of pulp and paper. Grew up in a mill town. And all my friends, pretty much when you got out of high school, you went down and you tried to get a job at the paper mill because it was probably the best paying job you could find, and it was the most secure. So I didn't do that. I went to college and got a degree and found my way to Chesterton and worked in Wisconsin and Upper Michigan in the paper mills for about 7 years. And then Chesterton transferred me to North Carolina to work and develop the pulp and paper industry in North and South Carolina and across the Southeast. So I guess long and short of it is I'm pretty familiar with virtually every paper mill east of the Mississippi. I've probably been there once, sometimes multiple times. And the interesting thing is when I was in Wisconsin, I worked with a company, it's been purchased, but it was out of Green Bay. And a man called me and he said, "Hey, I really am tired of putting water on my packing. Can you help me?" And Vince, I was so green. I had like maybe 120 days in the business. But when I went to Chesterton training, they explained about a product that was a pure carbon yarn product that had no PTFE on it. And what that means is having no PTFE, it would not glaze or get hard and damage the shaft. Well, when I say I was green, I also went and was trained on mechanical seals. I'm a full line person at the time. And so when I was trained in mechanical seals, they taught me that a seal had a soft face and a hard face. So I was so green, I thought, wait a minute, a soft face in the mechanical seal is made out of carbon graphite. And this packing material is 97% pure carbon graphite. PTFE on it, so it can't glaze. And it's lubricated with molybdenum disulfide. So it actually has a lubricant on the carbon yarn. And the carbon yarn is already the second lowest coefficient of friction in any fiber.
That's
next
right.
to PTFE.
Yeah.
So I thought, wait a minute, if I have a flat surface like a good clean sleeve and I put this carbon yarn packing on a good clean sleeve, I can quote put in a braided mechanical seal. Because up till this time, everybody ran water, squirted water into the pump and trying to cool it off or try to push dirt away. And the interesting thing is that in my mind, if we installed this appropriately, it wouldn't score the shaft. It would run smooth, and it literally would run like a mechanical seal because the carbon fiber was, in effect, much like the soft face of a mechanical seal. And the sleeve, the new sleeve, without any damage on it, when the pump was put in, either rebuilt or new, was smooth and flat, and it would be the flat hard face, the spinning hard face. So I had a spinning hard face, and the packing act is a stationary unit, and lo and behold, it worked like a dream
Without water, without the need of water.
without any water. And so that started my life of waterless packing. And it was funny because it just took off, and for the most part, it all went to paper. And the funny thing about it is the packing is black, and most of the paper, or almost all of the paper we sold it to, was white.
Absolutely.
And people were like, "Oh, I can't put black packing in my pump." And the interesting thing is, I tried to explain to them, wait, the stuffing box has a positive pressure on the outside of the pump. It's atmospheric. So if anything's going to go anywhere, where it's going to go outside, it's going to go out. So it's not going to go in. And after 43 years, we've never contaminated any white stock. And predominantly 90% of the packing has been installed in white paper stock.
That's amazing. Now,
and what's even more interesting is that I've been at this for so long. I happen to look back at my records, and I found an old presentation all the way back to 1981. And I made a comment in the presentation that I made at a meeting, that if they only used a gallon a minute, it would be 525,600 gallons of water a year. Well, come to find out, later in my career at Chesterton, I actually worked on water savings projects, and the average centrifugal pump in a paper mill uses 4.1 gallons per minute. So multiply that 500,000 gallons times 4, and that's what a pump uses every year. And so if if somebody used this product, they're going to save all of that. And not only that, it doesn't leak. It's can survive the untrained installer. Doesn't wear the equipment. Because it doesn't leak, the bearings don't get contaminated, and a piece of equipment runs longer. So it's really quite amazing.
So it's almost difficult to calculate how much water you've saved over those years. I mean, it's 2 million gallons a year per centrifugal pump, right?
Right.
So how many pumps are out there that have this? It's just got to be unbelievable. I mean, the contribution.
How many pumps are out there or that could use it?
Yeah.
Oh,
Just
I can't even give you a number, because there are, one of the things about being global now is I've learned a lot about the world, and I was dumbfounded to find out that Brazil had 250 paper mills in it alone. Okay.
wow.
And there are 450 paper mills in the United States. You would have to, each mill would have hundreds of pumps or mixers or other pieces of equipment, because it doesn't just run in pumps. It could run in mixers, and we did mixers. We did all kinds of different pieces of equipment. So I can't put a number on it. It would be mind-boggling for me. And when I got the number, no one would believe what I was telling them anyway.
Yeah.
Because it was large.
Wow. That is just a big wow. I mean, that is amazing. So, for many people that are out there that are interested in sustainability, I mean, you get the A+ award for sure. I'm sure.
Well, and I think that one of the things that is funny is, it's not what the water costs. It's what the water costs to use it and get rid of it.
Right.
Years ago, it was not a big deal, because everybody said, "Hey, look, we got a river right next to our plant. We got all the water we need." Yeah, but there's just one problem. Sooner or later, you're gonna have to put it back, and you're gonna have to put it back cleaner than what you took it from. And if you don't use it at all, then you don't have to worry about it. So it was really pretty funny, because we kind of stumbled onto it. And then once we got going, it was funny because over the years, like we've all had different opportunities within a company. I worked in Wisconsin and Upper Michigan, and the sales grew exponentially over 7 years. And then I got transferred to North and South Carolina, where they did no business in this product. And 5 years later, they were the world's leader of waterless packing. It had nothing to do with me. It was me teaching customers and salespeople how to make it work and how to save the money, how to save the water, how to make the equipment last longer. And of course, you know, everyone was interested in that. And lo and behold, guess I get transferred again. So I now have Alabama, Mississippi, and the panhandle of Florida. I think you already know the answer to what happened then. It all started all over again.
Yeah, sure.
I was lucky enough to get involved, and Chesterton was lucky enough to give me the opportunity. I say that lucky for both of us because I learned and they learned. We did an industry school and strictly on pulp and paper. And we introduced this product to the Nordic countries. And about 120 days later, I found myself in Sweden. Well, the name like Johansson, everybody's name is Johansson in Sweden.
Yeah.
The only
So
thing
you-
is like,
You fit right in, I guess.
what?
I guess you fit right in there.
Well, I kind of did and kind of didn't because it's supposed to be Johannsson. And I had a great grandfather who removed the S from his name. So when I got there, everybody goes, "Hey, what happened to the other S?" So I had to tell them. But the point is I went there, I was there for about 21 days, traveled all over Sweden and some other parts of the area. And you know the story.
Yeah.
I mean, yeah, it's still functioning, still works. The interesting thing about it is it's one of those situations where the product is so well made, it's kind of like, hey, wait a minute, there's got to be something better.
Yeah.
There's something newer.
Right.
And the interesting thing is there are a lot of different materials and there are a lot of different people who've tried to make waterless packing and do it. But I think one of the things that's interesting about this particular situation that I'm in is I don't have to buy any bushings. I don't have to buy anything special. There is a unique way, and we have to train the people on how to install it a little bit different than normal. But in the end, it's just braided mechanical packing installed in a pump or a mixer, and it runs years.
Yeah, that's amazing. So I don't want to put you on the spot, but if you have any photos or examples of how it's installed or what it looks like, you're more than welcome to share the screen. You just have to hit that little green button that says share screen.
I do not.
Okay, that's fine. Let me ask you, I was looking at the right here, I was looking at a brochure and I'm wondering, would there be something in here that
That happens to be a brochure that I created.
well, there you go. Great minds think alike. I find myself saying that more over the years. So reduce packing, adjustment, and replacement. This would be one of the products, I assume.
Well, there's a couple of ways, and that's the interesting thing about it is there's several different ways that we can approach water savings. And
Yeah.
certainly, right now you're in a very unique spot where we have something that it's a company that it's called Spiral Track. You can see it in there in that brochure. And it's basically a bushing that takes two of the rings of packing out. And what we have the ability to do is we literally can control the amount of water that we put into the product. And we can tell people, okay, here, you're running this piece of equipment at this speed, at this shaft, and we're going to tell you exactly how much water, if you want to put water on it, to put in it. And then the other thing is there was a device that you saw called Connect. One of the
Yes.
things we're working with the Connect is we're actually measuring the water pressure. And by measuring the water pressure, and we know how many gallons of water is going through the size of the pump, we can actually calculate how much water they're using.
So
And
that's
at
this
this,
right here, correct?
right,
Okay.
right. So we can actually determine how much water they're actually putting into the pump. And when we can do that, one of the things that I think is important today is once we know how much water we're putting in, and when we know the speed of the piece of equipment and we know the shaft size, we can actually determine how much water they need to use rather than how much they are using. And then we can actually tell them how much water to use. And that's very important. And when we're using the particular product I'm talking about, I mentioned that the average pump uses 4.1 gallons per minute. And we're talking about if you would use the waterless packing option that I'm talking about, you can either run, depending upon the speed, with no water, or we're literally running as low as a gallon per minute, if that. And
So,
and the fact of the matter is the reliability goes up. The sustainability, as everybody's worried about, especially now, everyone's environmentally conscious. And I think what's always funny is when I've always said, well, my subject matter is pulp and paper. I'll go, oh my God, that stinky industry. And I don't think that way. I think, hey, how do we save them water? How do we put the water back that's cleaner? How do they don't have to use the water? So it's an interesting industry. And the funny thing about it is everybody goes, well, paper's going to go away. No, it's not. Paper's not going away. First of all, we're humans, so we're going to have tissue and we're going to have toilet paper, and we're going to have paper towels, we're going to have all of these other things. And people go, well, there's no more newspapers. That's true. But one of the things, Vince, that's really interesting, and as I was reading this morning, in fact, I was reading about people buy online.
that's right.
But what the companies have realized is they're sending catalogs out again because the people kind of like to look and page through a catalog, and they get those great catalogs. But the interesting thing is there's no prices in it, but there's a part number. And now it's just like the catalog before, where you used to order from the catalog. But now what you do is you get the part number and you go to online. But there still have to have, and it's growing every day, the amount of catalogs and different print materials that are coming out that everybody thought were going to be gone with the advent of online ordering.
Yeah.
And so it's really interesting. And
But to that point, then the other side of the equation is because people are buying online, they're buying a significant amount of items that are then boxed up and wrapped with paper, albeit it may not be white paper, it might be brown paper, but it's cardboard or some corrugated type material. But we thought paper was going to go away, but with the advent of Amazon and other delivery mechanisms like that, I'm sure it just kind of replaced one industry or one demand for paper for the other, if you will.
That's exactly right. And what's really funny, I was standing outside a paper mill one day, and the FedEx driver drove up, and I said, how's it going? And he said, oh, I can't deliver all of the boxes I have to deliver every day. And I thought to myself, oh my gosh, that's right. And just like you just said, the brown paper industry was on its way out. It was going down, and everybody was headed toward white, or they're going to absorbents, or they're going to all kinds of different products. And as soon as online purchasing came around, the brown paper industry is booming.
Yeah.
We can't make enough. And the interesting thing is it's global, because it's, things are being shipped all around the world. And it's
Sure.
like you say, so it's very interesting. And so the beauty of the brown paper industry is you don't get the argument of, oh my gosh, my stock is brown and your packaging is black. Nope, don't have a problem with that. If you'd like to save water, we can really help you.
Yeah.
So our opportunities are endless. I think the interesting thing is people have to have an open mind. And there are times when people go, well, it's packing, it's going to wear my equipment, but it's carbon yarn, but it doesn't. It's got the second lowest coefficient of friction known to man. Yeah. It's pretty much the same material as in a mechanical seal that you want to buy. And it's split, so you don't have to take your piece of equipment for it.
Right.
So yeah, so they're and then the other thing I didn't even mention is it really doesn't use any water. It doesn't leak either. So the housekeeping costs and all of the issues that are with cleaning up or dealing with all of that, there aren't any and then it lasts for years. So the water savings is one of probably 6 or 7 great benefits of the waterless product and the waterless idea. And like I said, it's everybody's tried to copy it or come up with a new iteration of it. But the fact of the matter is it uh, it still works, and it's been working for 42 years.
That's
Pretty amazing.
amazing. That is a great story. And, this is kind of directed right at the pulp and paper industry. I mean, if you're not, why not? If you're not utilizing this method to save water, why wouldn't you? So hopefully somebody in the pulp and paper industry is paying attention and thinking, I need to give that George a call, be
I
great.
think what's really interesting is people are like resistant to change.
Oh, yeah.
You've heard this. I've heard this, especially as I get older. Well, that's just not the way we do things here. Well, okay.
Yeah.
That's kind of scary, but okay.
I hear that.
And I think one of the things is there will be people. And the other thing there were people that would try things, and now there are so many things where people kind of have to follow the rules.
Yeah.
And that's a bad term, but it's not necessarily regulations, but well, I just can't be trying things on a wing and a prayer. But the
Yeah.
fact of the matter, we've got it documented. I mean, it's amazing how well it works, and it's gotten to the point now where people will sometimes call me up and they go, "Hey, it didn't work very well," and so I said, "Can I just come and visit?" And they said, "Well, what do you want to do?" I said, "Well, let's try it again, but I want to watch how you put it in." And then, the interesting thing about people is we're always trying to find a shortcut. And so they've gone away from the slight little nuances of the installation process, and that makes a difference between success and failure. And so when I see it, I stop it and we get involved, and then it goes right back the way it was. And it's just really, really interesting, and it's kind of cool. I'm kind of glad you called me because it energizes me emotionally to kind of get back into it, because
Right.
I take it, I just like, yeah, well, it's water. Yeah, I know, and I understand they use millions and millions of gallons of water a day, but the fact of the matter is water is clean water is a shortage,
Yeah.
and tremendous
Well,
amount of regulation put on it.
well, George, tell me this. I mean, maybe we don't have visual examples, but what is the correct way to install it? That's no trade secret, I'm assuming. So what what
It's
happens
not.
that what happens when they cut corners and when they do it the method that you've developed? I mean, what is that method? Because we're talking
Well,
about like a
generally, yeah, a piece of equipment, a pump or a mixer has, it will probably have 2 rings of packing, and then there's something called the lantern ring. There will be 3 more rings of packing in behind that. And then there'll be a gland follower where you tighten the gland. And basically what happens is when people take the pump apart, or they're going to take the packing out, the old packing out, they pull it all out. And then what they will do is the problem is people take the old piece of packing, they'll lay it on a table, and they'll cut the new piece of packing to the same size as the old piece of packing. The problem
okay,
with that is they're now short. Okay. To compound that, they will take the piece of packing, they'll put it around the shaft. And when they put it around the shaft, then they're going to push it in with the gland follower. Well, we have basically 3 inches that we have to fill up. But the gland follower only has maybe at the most 3/4 of an inch. So it will push it in 3/4 of an inch. Then they'll get another ring of packing. They'll cut it, they'll stagger the joint, and they'll push it in with a gland follower. Well, the interesting thing is is then they'll put the lantern ring in, the water ring where the water goes in, and then they'll do the same process all the way out with the remaining 3 rings. And there'll be, usually will be a little bit of packing hanging out of this packing box. And then they'll tighten it and try to cram that in. And sometimes it will go in and sometimes it won't. And when it doesn't, then the gland filer will get trapped. It will trap the packing between the gland filer and the bore of the stuffing box. And when it does that, you can wring the studs off the pump. They're never going to adjust that packing. Well, the interesting thing about using this product that I'm talking about, the waterless product, is we do it differently. We have a tamping tool, and Chesterton makes them. But what we do is when we get the first ring, we push it all the way down to the bottom of the box and we engage it. We make sure that it is in the bottom of the box and it's engaged and it's there. And we tamp each ring with a tamping tool all the way up. And so when we do that, all of the rings are engaged. When you use the gland follower method, if the packing's all in the box, but you tighten it down, all of the force of the gland load is lost in the first 2 rings of packing. So the rings, and the most important rings by the product itself, are not engaged. So the product immediately invades into the stuffing box. And at that point, the packing only has one option, and that's head for failure. Yeah. But when you engage the bottom rings in the bottom of the box and they're seated appropriately, and the whole packing set then becomes a column. So when you adjust the gland nuts at the back of the stuffing box and you tighten it, the whole column works together, and the fluid leakage doesn't get into the stuffing box, and it doesn't start to degrade the packing. So the packing works longer, lasts longer, is not contaminated, and it's actually the first few rings are actually sealing, where in the other scenario that I described, right, they're not.
Right.
And so
there's a certain quality of lubricity to this carbon-based material that prevents deterioration of the shaft, I guess, if I'm wording that properly. I mean, if there's lubricity to that carbon material, then it's just going to last longer without the need of water, which was the whole reason why they used water to begin with. Am I right? Or was that?
That's correct. There's 2 reasons why you use water. One is if the pump were in a lift position, packing material, when it first was invented, could not seal a vacuum. So then if you have 7% air in a pump and you're in a lift position, it will suck air and you'll lose prime. So then somebody came up with the idea of we'll put a ring in there where we can put water in it, which will stop the thing and will suck water into the pump rather than air, and we won't lose prime. And we'll get an added benefit of cooling the packing off. Well, it's different now because the carbon yarn, and we do braid it differently. We do braid it on a different braiding machine than most of our other products. It's called an inverted braider. And so it's also lubricated with something called molybdenum disulfide. And molybdenum disulfide is very resistant to water washout. So the interesting thing is not only do you have a carbon yarn fiber, but now you have literally a lubricant of molybdenum disulfide, which they make greases out of. Yeah. So now we have a wet lubricant that's on the product that actually acts as a barrier and reduces the ability for the fluid to wick through the product. So it only enhances the product. And the interesting thing is in many instances, most of the piece of equipment, I take the lantern ring out because I don't need the water ring. So I get an additional ring of packing, and I don't need the lantern ring because I'm not putting water in it. And the packing can seal a vacuum, so it won't suck air, it won't lose prime. And by doing all of that, it reduces costs and lasts longer. And the sleeve is not worn because not only is it a carbon yarn fiber, but it also has molybdenum disulfide on it, which is a lubricant in its own right. So there's virtually no sleeve wear.
I'm trying to, I think you answered this question, but the reason why somebody would choose not to is just because they've been they've been staying within the box. They color inside the box and they stay within those 9 dots, and they really just don't open up their mind and think. I can't think of another reason why somebody wouldn't want to at least try it.
Well, yeah, the interesting thing yeah, it has to run on a good sleeve. If the sleeve is scored or damaged, it will not work.
Well, that's a different
So
story. Yeah.
the interesting thing about when I would talk to people about it, I said, hey, you have pieces of equipment out there that are already running. My suggestion to you is if you have an interest in doing this and you're going to replace a power end or you're going to replace the drive end of the pump and it's going to have a new sleeve, that's the time to do it. And, 40 years ago, I was young. So I would jokingly say to the people, I said, I'm only 25. I can wait.
Good for you. I love it. It's a beautiful sales technique. I can wait.
A man who was totally convinced that this was going to work.
Yeah.
And he says, I'll try 10 pounds. And because it's a packing material, it's more expensive than what most people are buying in terms of price. But in terms of value, is way less. But it was, I'll try 10 pounds. And I said, sir, you'll enjoy 2 pounds and love it. I knew he was going to have to take this as a maintenance supervisor to his plant manager. It was a tiny little mill. And the interesting thing about it is he did have to take it to the plant manager, and his plant manager called me and he says, are you out of your mind? I said, no, you won't believe how well this will work. And he was like way early in the process. And it was probably within a year that whole mill was converted and over particular product.
Just
and he was a fan that he literally would take calls from around the world and tell people.
Wow.
It was really quite amazing. And he was in Beloit, Wisconsin. It was very funny. But
wow.
Yeah. And their mill was, they made basically box material. So he was really an amazing person, and he was all gung ho. And I said, well, we'll let's go slow. We'll get there. So you'll find out how well it works, and we'll teach you how it goes and everything. And if you have a concern, you just give us a call. And he never called us. And I was wondering how it was working, but I noticed that they were buying more, and he literally now in the United States, a mill like his they would have to be closed. You can't discharge anything to the river anymore. So it's even more important for them not to use water.
Yeah, yeah, so true. I was just going to poke around on your AW Chesterton. Can you see that? 140 years of excellence. I don't know if that just flashed up there. Something to be very proud of, the Chesterton name. And so we're going to go to pump packing, right?
Correct.
Okay. And then application specific. It takes a second to populate. So here it is. Now I'm looking at 2211, 377, and 370. So let's just tell me a little bit about what I'm looking at. And this looks like one of these two are one of the ones that you were chatting about that help save the water.
Sure. Well, the 370 is the original product, and it was introduced before I even started at Chesterton. So that means it was over 43 years. And the unique thing about it is that what's unique about it is the fiber starts out as a piece of rayon. And then what happens is the fiber is then heat treated in a oxygen-free environment until it gets to 97 to 98% pure carbon graphite. And the beauty of that is pure carbon graphite has the second lowest coefficient of friction in the world. And so it's really soft on the sleeve. The unique thing about it is when we build the fiber, and then Chesterton buys the fiber and we're going to build the product, what we do is we lubricate the product. Every fiber that's in that braided packing is lubricated with molybdenum disulfide and a break-in lubricant, which allows it to survive in the first 15 seconds of start. So the interesting thing about that particular product is, as I mentioned earlier today, it's braided in an inverted style. So that means that the fibers come together right through a pan of lubricant. So there's more lubricant and there's more blocking agent in that particular product to make it work. And that's how it is able to run waterless and not have to use cooling water or any kind of lubrication to make it survive. So that's the that's the product that I've been involved with, and literally, I don't know how to say this. I don't want to be bragging, but
Do it. Put it on the map.
There's tons of it. I
You
mean,
put
literally, there have
370 on the
been
map.
tons
Well,
of
you
that
should be,
product sold.
I mean, you got to be
across
proud
the
of
world.
that. That's awesome. I'm looking at the applications here. Yeah, I mean, this
Right, right.
refiners.
Those, if you notice, they're all almost all of those are in paper.
Yeah.
The pulpers, the stock pumps, the agitators, the fan pumps. The fan pump is a pump that pumps the stock to the head box of the paper machine, and then which is then laid on the screen. And the vacuum pumps, condensate pumps, all of those. Yep, every one of
All
those
right.
pieces of equipment is a paper mill.
I'm going to stay with this website for a second because being a rookie, I thought you were talking about this product.
I would like to speak about that product
Yeah,
because that was
please.
introduced just 2 years ago.
Okay, let's talk
And
about that.
things change, and the way that product is made, it is a carbon fiber. It's a pure carbon fiber and continuous filament. And the unique thing about this particular fiber is it's made in a different way. It's a series of monomers and um, polymers that are reacted and put into a reactor. And then, like any other non-asbestos material, they react that under heat and pressure, and they get a mix that's a liquid mix. And then they're going to extrude that through what's known as a spinneret. And when they push it through the spinneret is basically they're literally extruding the fiber through a tiny little hole. And what they can do by doing that is there's a push-pull. As it starts to go through the spinneret, the polymer or the carbon material is being pushed through the spinneret. As it goes through it, it's pushed through. And then eventually, as it starts coming out the other side, as it cools off a little bit, then there's enough tension to it where they can pull it, and they pull it down into a cooling bath, and it cools out. And the beauty of this is they can really control the denier of the fiber or the size of the fiber itself. The unique thing about changing the way this fiber is made is it still has all of the benefits of the rayon-based fiber that's been heat treated, but in this particular instance, this particular fiber is much more resistant to wear. It's stronger, and it has the ability to be put into pieces of equipment that might have some sleeve wear or have some minor wear on it, where the other product would potentially shred or fail.
Right.
This one you can put on something that might be a little bit more worn, and it will still survive and work. pH is the same, speed is the same, everything's the same. It's, I mentioned earlier when we were talking, I said, things change. Well, this is a different way of making carbon fiber. And by doing so, technology has made it better, not worse. So it's a very interesting product. It does allow us to get into a little bit wider chemical capability, and it allows us to work in pieces of equipment that we have never been able to work in before because it has a different lubrication system. It is braided the same. However, it allows us to go into some very critical applications in paper where it would be like the continuous digester and the outlet device, or the top separator, or the high pressure feeder, or the low pressure feeder, and the steaming vessel. All of those are in the pulp mill. All of those are where they cook the chip. And in the past, we have had kind of a blind spot there. And this particular product with new technology allows us to even enhance the opportunity in pulp and paper.
Yeah, that's amazing. I like the fact that the sleeve could have a little bit of wear and still utilize the 377. I've seen wear on a sleeve, and well, I've seen various types of wear, some of which looks like almost an undulation, like wave pattern. Some of it
Right.
actually looks a little bit more violent, almost like uh, pitting, you know.
Mm-hmm.
But I'm going to show the screen again. I'm seeing the applications for the 377 fiber here, Chesterton 377 Carb Max. Looking at your website, and I see everything, all things paper and pulp industry for sure, but other rotating equipment in a variety of industries caught my eye. Can you tell me some of the other industries that would utilize that? Thinking volatile chemical, maybe, or
Well, they could go to chemical, absolutely, because it has a pH of 0 to 14. And they could go to chemical in the way the product is designed. They could go to chemical. The interesting thing about chemicals today is most of them use mechanical seals, but this is a situation where we've had great success in dealing with various caustics and acids where necessarily seals may not work. And this is a situation where because we have a good solid braid and a nice construction with a solid fiber and a good lubrication system, we can literally put it in and it will work in bigger pieces of equipment where cost of a mechanical seal will be prohibitive, where this would not be. So there, you could use it in the power industry. There's still coal-fired power plants and other different kinds of power plants. Surprisingly, one of the things that's on the horizon, and it goes up and down is wood pellet operations, where wood pellet power plants are starting to come online. They're very big in Europe. They're not quite so large as an opportunity in the United States. However, this is a situation where this particular product could do very well in handling any kind of the ash or anything that would come out of burning either coal and or wood pellets. So yeah, there's just a few of the other industries.
yeah, right now
And
I'm
of
in
course,
Italy, and you're right. The wood pellet industry it's even within the last 2 years, it's had some kind of an exponential growth. The wood pellet industry, and of course, you got to get rid of the ash. So that's
right.
yeah. But
Yeah.
interesting. Are you going to be at any trade shows or anything coming up, or do you?
Well, we are in trade shows all the time
Oh yeah,
at this time because our focus is, as you're well aware, is we have four industry leaders and we're focusing on four particular industries. Industries are pulp and paper, mining, wastewater, water, and a marine. There's not been anyone in the pulp and paper genre before, so I'm a little behind the eight ball. I'm working on trying to come up with some trade shows, but at this point in time, we're looking at trying to get involved with a number of different things, but we don't have anything coming up on the horizon.
yeah, that's fine. I was just curious. I just got back from EFAT, which is a big wastewater show, and I'll be going to Akima in Frankfurt, Germany, and then soon WEFTEC will be coming up in the U.S. and
Right?
a few other shows. So it's just one of those things where it's been delightful to chat with you. I mean, we did have an initial phone call a month ago or so, but to see you in person and to learn more after hearing the conversation on the phone and learning a little bit more about the company and the product, 140-year-old company, that's something to be proud of. You were there for more than 40 of those years, and it's
Yeah,
pretty cool.
I my it's funny. My kids say I'm mathematically challenged because when I first started, my wife asked me, "Well, what do you think?" I said, "Well, it's an interesting company. I think I'll give them a couple of years. And I told that to my son once. He says, Dad, 43 years is not a couple of years. I think you're mathematically challenged. But the interesting thing is that they've been great to me, and I've had the opportunity. I just completed a a, a week long school in pulp and paper at Chesterton. We had 32 attendees. Hopefully, we're going to do one in the West later this year, and it's predominantly we're trying to, at this point in time. The one that I just did was for our salespeople and some of our field people. However, I'm interested in doing like a industry symposium in a hotel where I can invite people, and we'll have it in an area which is pulp and paper rich, and they can come, and we'll have speakers of various things and of various products across our line and some other things that of people that we work with, and that's something that's on the horizon.
It's interesting that you said that. Who knows? We do a little annual. It's called the Empowering Pumps in Industry conference, not a symposium, but it's an intimate group, small, of attendees. Here, let me show you a visual of that, and maybe we could put something together in the future. I don't know. I mean, I'm not the one that would decide something like that, but it's certainly worth taking a quick look at. And maybe you can call it a shameless plug for me, but this is our website, Empowering Pumps and Industry. And you'll see down here the Empowering Pumps and Industry Conference.
Mm-hmm.
If you click on that, you'll notice that we're hosting one at the Colorado School of Mines. Now, before I I want to preface this by saying it is at the School of Mines. We will do some type of a tour related to the mining industry, but it's not beholden to just the mine industry. So various people will be showing up. And let me show you who some of those exhibitors are. Bingo. You guys are there and you're a big sponsor. So,
Right.
yeah, which is pretty exciting. And if you can, I'd love to see you join us in Colorado. It's this November. But more importantly, we do things every year. We do these trade shows every year, these conferences, if you will. So
Right.
last year we did one in Atlanta, Georgia. We did one in Pasadena, Texas, a couple of years ago. It's just there's a couple of examples on the YouTube videos here that you can see. But the point I'm making is maybe someday we can get near a location that's centric to the pulp and paper industry, and you can give have the floor, if you will.
Well, that'd be great. I think the interesting thing about it is when you look at the southeast, you have Atlanta or you have Charlotte, and the beauty of Charlotte is a hub for American Airlines, so it's easy to get to. But you also have in the near southeast and just north and South Carolina and Virginia, you have 33 paper mills.
Oh yeah.
So yeah, yeah, that's very interesting. I
Yeah.
would love to do it. It's um, again, I don't mean to blow my own horn, but one of our people who's been with us for 28 years says it was the best Chesterton training he's ever had.
Oh, I
I was
love
pretty
that.
I was pretty
Really.
excited about that.
Yeah.
Yeah, I really was. And
So,
it's kind of funny because I was born in a little dinky town in northern Wisconsin. And for myself to get this far, I'm pretty proud of myself. But you gotta stay humble and realize that you learn every day. And if the day you decide you know it all, you're going to meet the person who does, and they're going to tell you about it.
that's right. There's, in a way, yeah, there's always going to be somebody bigger, stronger, or whatever. There's always
Right.
something that some force can humble you, but you're a great guy and a smart guy, and this is quite a story. And you really helped shape the sustainability aspect of water. I have to tell you that that is in and of itself just a fantastic byproduct of your desire to break the barrier of we've always done it this way. Well, let's not try it that way. And so let me ask you this. What do you got going on now? Anything new, or is there any new product that we can talk about or new developments? I don't want to give away any trade secrets, but
Well, we have
anything?
something, we have it running, and it's running in pulp and paper. It's running also in hydro. And
Okay.
maybe may have heard about it. It's called amps.
Amps?
And and basically I'm excited about it because we have the ability to actually use small hydraulic or pneumatic cylinders that load the packing follower that keep the packing under adjustment so it lasts longer. And I'm excited about it because I want to use this amps device with the product we've been talking about, where literally the packing will be self-adjusting. And one of the things that's been happening in the industry is, for safety concerns, paper companies won't let maintenance people adjust packing while the equipment's running. Well,
Yes.
I'm excited about this automated mechanical packing adjustment because all they have to do is, if they want to change the load on the packing, all they have to do is turn a air regulator valve and it will adjust the packing. So I'm excited about it because it doesn't, I don't have to worry about whether or not somebody's paying attention to it or not, because it's doing it automatically. So
Right.
it's
So
called
if I,
amps. I'm really excited about it.
let me
And
share this with you. I'm gonna I the, you know I the way I do things on this lunch and learn is it's just truly an exploration. So the last year that we did the at the water tower at in Beaufort, Georgia. Now I'm not going to play the audio and all the music and all that, but there's a scene in here where of course, we did a tour of a water wastewater facility. But I want you to see it if you recognize Ron Frizzard.
sure,
There,
there you go. There's amps.
there's Amps right there, buddy.
Yeah,
I was
yeah.
I had the pleasure of sitting in on a couple of his demonstrations at the water tower again in just outside of Atlanta, Georgia, and I was fascinated. Basically, it's kind of like I don't know if you call it an air pocket, but he showed me how the air pressure basically creates this consistent. Uh, Maybe you should take over and tell me from there, but it basically can, has the ability to keep the correct pressure on there. So
That's exactly right. The air, it can be air or it can be hydraulic.
yeah,
And it will keep a consistent load on the packing follower, so the packing is always adjusted. And so for my end of the business, where I'm
right,
talking about waterless and we don't want to use water, we can set the amps to make sure that it's always appropriately adjusted. So we don't have to worry about people loosening it up because oh my God, it's too tight,
right.
or tightening it too tight, and then they're going to try to overheat it. If we use amps, we can put it right where we want it, and we'll get maximum life and the best value and best utility.
I love it. Let me show you one last picture of the event here. Um, there's there's
There he
about I'm
is.
sure you're good friends with Ron, I would imagine. And that's Nick with Homa Pumps right there, a pump company.
Okay.
And again, that's at the Epic last year, and coming up in November, we got that one this year. So in at the Colorado School of Mines. But yeah, that's a. I'm glad you brought up amps because I actually saw it there, and then I saw it again. Let's see, where was I? I was at another trade show a couple of months back, and I think I went to the table and they had an example of amps there too. I'm trying to remember. Oh,
Yeah,
it was the SME show, the Mine Exchange in Arizona,
right.
Phoenix, Arizona, and I got to see it there
I,
firsthand.
I'm really excited about it because we have some installed on pulpers in a paper mill with the 377, the newer product,
Right,
and
I
it's
got it.
working really, really well. So I'm keeping my eye on that. And the interesting thing is um, I think it's the future. I really do. Between those, I think everything will in people will go, wow, I can use this particular fiber and this particular braid and packing, and I can put amps on it, and I'm going to extend my life times 3 or 4 or 5. And reduce water, reduce maintenance, reduce pollution, reduce housekeeping. The list just goes on and on and on, and it's exciting.
Right. So in addition to the all of the ones you just named, you also reduce. It's also a safety. You're reducing the risk of slip and falls if you're not having fluids, which over the years has been just an accepted practice to have dripping and fluid coming out, and it's just the way the pump runs, right? But that's slip and fall opportunity too. So you not only have the disposal of that water, but then you got to clean it up and make sure it's not gathering anywhere. And so yeah, there's at least 7 benefits that I can imagine. So probably
Oh, for
more.
sure.
Yeah. Well, let me tell you
Yep.
something. This, George, has been really a highlight for me and my lunch and learn recording. So I just can't thank you enough for taking a little time. Generally, after I wrap up with these kind of things, I like to ask people a couple of questions. So, what do you like to do for fun?
Well, I'm an avid golfer, and I'm a good one. Um, Over the years, my handicap right now at 69 years old is 6. But
Wow,
come summer, it'll probably be 1 or 2. And
really?
I don't move up. I'm still playing pretty far back, so I really like to do that. My game isn't as good as it used to be because one of the joys of my life is I have 5 grandchildren.
There you go. That's the
And
next question I was going to ask is, besides golf, what else brings you joy? And so, family.
yeah, without a doubt. And I'm so very proud of my children, and they're all successful. And the 5 grandchild children, I have just this week, last weekend, I had one of my youngest grandson was here, and my son has a turf grass degree, so he used to work at Chapel Hill Country Club, and he brought me a hitting mat, and it sits at the end of my driveway. And I don't live in a huge golf community. I have just enough space where if I go get foam balls, I can hit off this hitting mat and I can hit it to the backyard without hitting it in the woods.
Right.
And so I had my grandson here over the weekend, and I gave him a club, and I was thrilled and amazed at his ability. He's 8, and he's probably the most far along hand-eye coordinated kid I've ever seen in my life. It's
Wow.
unbelievable. I handed him a golf club, he picked it up, and the next thing I know, he's hitting it up in the air after about 3 balls with a slight drop.
Nice. That's
So,
fantastic. Well, continue to
yeah.
encourage him there. You never know. I mean, he may be on the
Well,
tour.
I started when I was 5, and I wanted to be a pro, and I kind of went off to Florida and stayed there for a while and realized this I wasn't quite good enough or committed enough to do it. So I came back
Well,
home. But
that actually brings me to my next question, and that is if you could share one life lesson to anybody that's listening right now, what would you say to them? What would the best advice that you can offer to just a person listening to this video?
well, a couple of very famous people said it. First, it was Winston Churchill, and then it was Jim Valvano. Never give up. Just never give up. It's not always going to go your way, but if you are committed and believe, it will happen.
I
And
love that. George,
ask for help.
yeah,
Ask for help if you
ask
need
for
it.
help, but never give up is you are preaching to the choir, my friend. That is a great way to wrap up this show. And again, I can't thank you enough. If you've enjoyed this Lunch and Learn, please like and share with your friends and your coworkers and anybody else that watches this. But George, it's been delightful, and thank you for having us.
Thank you. It's been a pleasure.
You know,
Yeah.